I'd like to demonstrate Cimatron on a 5-axis aerospace part. As you can see, it brought the part in with the relevant coordinate system for the center of rotation down here. And also in here we have the stock model. I'm going to begin by creating a coordinate system. When I pick the whole apart, it gives me a bounding box with possible places to put the coordinate system. I'm going to be at the high point and in the center, and this will just make it a bit easier for working with a template. In fact, I'm going to rename this one too, and we'll call this side 1. And we're going to apply a template. Okay, so we've got the roughing done with the 3/4 inch cutter from the top side, and now I want to work on doing a 2D path across the top face. And in order to facilitate that, I want to create another coordinate system. This time we'll say that the Z is normal to this face, and we're going to call this one 1.1. And then for the contour, I'm going to pick 1x1 projected. So we're going to start here and work our way around the part. And we're going to be machining to this plane right there, and our boundary curve is going to be set to on. Alright, let's look at that in the navigator. Okay, let's see. Next, we're going to do the roughing from that same coordinate system. So looking down from the top, we're now going to be seeing it like this. And let's give ourselves a boundary. We only want to work on the inside of the part, so we'll do it like this. Alright, and then next, let's do the back side next. Okay, we need a coordinate system over here. So again, we do a datum, UCS, center of geometry, and normal to this plane. And let's take the time to rename it. Okay, we're going to work to this one. We're going to do a Z limit to that point right there. And then we're going to need another coordinate system on this side. Okay, then we're going to change this to be UCS side 6. Alright, and then in this case, we can make the Z limit bottom right here. And then we're going to do the right side. Rename the UCS. Make the Z limit this low point here. Notice I'm not using any boundaries in this. I'm letting the stock model dictate where to machine and where not to machine. Okay, now 1/4 inch flat. We're going to stay on this side. The table's already rotated to this position. So this one will also be side 3. And we're using a 1/4 inch flat. And everything here should be good. We're doing a finish pass all around, and we're going to machine down all the way to this point here. No boundaries. And then this will be the left side. And bottom limit is there. And then the back side and we'll limit the Z. Yeah, let's just go to here. Alright, then this one is finishing the floors. I'm pretty sure that was going to be these ears. Oops, wait a minute, that wasn't right. I need to put a coordinate system there. So we'll do datum, UCS, center of geometry, here and there, normal to face. Rename this one to side 5.1. Alright, now it'll see some faces of the machine. Okay. Then this one, 2x profile. Yeah, okay, I know what I'm doing here. So I'm going to do an intersection of these two faces with this face as a plane. And then when I do the 2x profile here, the contour will be this one and this one. And the plane is this level. And then let's do an extension. Let's just do a lot more. Let's do 0.75, and 0.75. Okay, there we go. Now what's this? Oh yes. Okay, so now we're gonna do these guys. I want to do a boundary here, and I want to show something that's kind of neat. For my boundary, I can pick surfaces, and it expands out based on that pick. So this can be my boundary, just like that. We can have 3D boundaries, which is pretty cool. Let's do one over here. Okay, there's a boundary there. And even though we have a boundary, I can also tell it that I want to be as touch point, which means that the cutter, based on the cutter geometry and the part geometry, it positions the tangency of the cutter perfectly to the boundary based on both geometries. Okay, let's do save and calculate. Oh, wait a minute, wrong UCS. Okay, now this might look funny, but let me show you the result. Here, the cutter is walking back and forth, cutting the top. Here it's putting on this shape on the ear. Takes a finished pass around the bottom. Puts on the chamfer over here. And this chamfer there. Or radius rather. Okay, front edge. Alright, now we're going back to side one for a second. Top view, and we're doing a roughing. We're going to rough out inside here. Let's go into the sketcher. I'm going to choose add geometry. I'm going to draw a line between these two corners. Then go to the top view, and we can drag this to whatever size we need it to be. That looks pretty good. And then we're going to go here, boundary, Part surfaces, we'll just say all, and execute. Next, now we're going to do picking over here on this side. Or wait a minute, side 6 is the left side. Alright, so let's do this. Let's sketch on this floor, and I'll choose add reference to this edge and this edge, and then we're going to do a box like this and like that. That's the only place I want that rougher to go into. Okay, now we're going to change this back to side 6. We're going to give it a boundary like this. All surfaces. Save and calculate. And then side 1. 1.1, that would be, yeah, this one. Okay, so now we need another coordinate system. I want to get tipped up normal to this face. So again, datum, UCS, center of geometry, working with this face. Or wait a minute, we already have that. We already have that. Yeah, we already have that. So this one is 1.1. And what we're trying to do right now is take care of these guys here. So let's go into this one, and when we go to boundaries, we can also pick floors. So watch me pick these boundaries by indicating these floors. And I could probably pick this one, but I wouldn't like the way that that looks, so I'm not going to do that one. We'll do it like that, and then I'll go into the sketcher for this face. If I choose add geometry, I can pick this whole face, and I get all those boundaries to come in, and I'm just going to delete these two and then reconnect the lines from here to there. Okay, so there's my boundary that I want. So real nice tools for making boundaries. Part surfaces, we can still say all. Save and calculate. And let's do a pick on this side. So here again we're doing the remachine. Let's go into the sketcher, choose add reference, and we'll take a couple of lines here. Then we'll go to the box tool, and I'm just going to draw a box like that. Like this, and like that, and then all the surfaces, and calculate. Alright, so we're almost done. We're just running around here and doing this to all the sides, and the software can keep track of where the material is and where it isn't. I do give it boundaries to help keep it out of areas where it might see stock, but normally we don't use too many boundaries. Rather than keep going around here and doing this, I just want to show a few other things. In fact, why don't we jump over to the finished part and we'll just show where we left off. So we started doing the picks. We had the picking done like this, like that, and then we got a 1/2 inch flat. This one comes in and does everything on the inside. And then a different tip. And then we did the chamfers. Did the tops of those bosses. Then a parallel cut to clean out that inside edge because of the angle. Couple of passes here with a 3/8 ball. Granted, I could have used one pass with a 1/2 inch ball, but I thought a couple of passes might be nicer than one pass. Then here's a doing that chamfered edge all the way down. Remachine with a 1/4 inch ball. Then this one is a pencil cut where we're picking this edge and this edge and giving us a single pass in between them. Another pencil, get those radiuses established. And then my favorite, auto drill. Now for auto drill, I'm going to have to demonstrate this one. Let me go in here and, well, in fact, let me back up. Let's just delete it from here. Okay, so we're starting the drilling from scratch. We go to procedure. Now it's recognizing in blue all of the holes that could be done. So we go to the group manager, we say, yeah, we want to do all these holes. Although we can exclude certain ones. Suppose that we want to do these in a different setup. We can unpick these bottom holes. Or we could flip the arrow and say that we want to do them from a different side. Yeah, I think we should do these from the other side as well. Okay, so we've committed to doing all of these holes, all at different angles. And we say OK. And then we do auto fit sequence because we've probably programmed these ones in the past. And by the way, this feature recognition is kind of unique in the industry. We define ranges. The best example I can give is that the thread for a 1/2 inch tap requires a drill diameter of 0.4219. Some designers might draw that hole at 421, another designer might draw it at 422, and another designer might draw it at 421 9/10. And what we do is we define our 1/2 inch tap template to look for a hole that has a range of 421 to 422. And anything that fits in that range is going to get the process of a 1/2 inch tapped hole. So I'm just going to say OK. Go ahead and do it. So it found 6 out of 8 holes. Save and calculate. Okay, and then the one group that got missed was this one, and it's also that one. So we'd have to go in and either manually program that one or attach one of these sequences to it. Let's see what that diameter is. Here we got 067, and here's 067. Could be that the way that that has a breach on this side may have caused it to not get found by the sequence, but we can easily attach it. So let's just go in there and do it real quick. We're going to choose define, modify a sequence, pick this group. It shows it to me like this, and then yeah, let's force a sequence onto it. So we tell it the drilling begins at DP. We can see that up here, this is how far we're going to drill. Then next we're going to drill from here to there. If we're satisfied with that, we can say save and calculate. Although I'm concerned that I don't have that pointing in the right direction too. Let's take a look. Okay, yeah, it did. It went from all the way through, so I gotta change that and tell it that this hole right here needs to come in that direction. So it's quite automatic but also quite flexible. It's a nice balance of automation and there we go. Okay, so there we go. We got it going correctly now. So even though those are all different angles, we can handle programming it together. And of course, if you only had a 4-axis, you could set it up to only search in 90-degree increments in one axis. So it's again, it's a nice blend of automation and user control. Okay, so let's also real quickly review the other procedures. We had the top procedure with the 3/4 inch cutter. At any time we can choose show me remaining stock, and the system will show us the remaining stock. We can also make it more or less transparent. We can do clipping. So here we can see what that stock looks like from the side. Then we had the 2-axis profile across the top. Then another rough spiral machine here. Then the top side, the 3/4. And by the way, these ones that I'm going around the outside with, I'm leaving 20 thousandths. You can see over here, why do we have so many more motions on this side? Well, let's have a look at the remaining stock from here. This is what the stock model looks like at that point. So you can see it's very efficient in chasing only the stock area and not giving us extra motions where they're not needed. Same thing over here. And now this one, you can see I went from a 3/4 inch cutter to a 1/4 inch cutter, which admittedly isn't a real popular approach, but I think it's perfectly fine. If you look at the number of passes I have here, let me just go into the navigator for a second. Let's hit play. It's not a lot of time spent on this floor, and there is a lot of picking to be done. So my argument is that for the couple extra passes you get on the floor, this is the right size tool for this task because it's getting into areas where a bigger cutter couldn't go. So if you go from a 3/4 to a 1/2 inch to a 1/4, the amount of time that you tool change probably takes longer than the extra couple of passes you get down here with the 1/4 inch cutter. And you can see that I'm getting a nice finish pass around all my features. Here I get the roughing motions because this has not been cleared out. So it's continuously tracking the stock, giving me roughing motions where they're needed and finishing motions where they're needed. So this is the approach that I did on all the sides. Here you can see the roughing motions, the extra passes around the features, and the floor machining. Same thing back here. The tops of those guys, the walls, establishing the rounds and the chamfers. Roughing down in here. Pick with a 1/8 inch flat. Oops. The finish procedure here again. Nice roughing motions, nice finish motions. Not a lot of material coming out of these areas. Another remachine. Finish with a 1/2 inch flat. Finish with a 1/2 inch flat on the appropriate tip for the back wall. Chamfers. Tops. Pick. Establish the rounds. The other round. Establish that chamfer. Remachine down there. Oops, same one. Pencil cuts. One pass in those areas. Also on this side. And then the auto drill. Okay, let's do an NC report. Alright, so down here under statistics, it shows the number of operations is 35, number of tools is 11, the total air time is 4 minutes, and the total feed time is 14 minutes, and the total time of feed and air is 19 minutes. But of course, that's in a perfect world without machine acceleration or deceleration. So I would expect it to run much longer than 20 minutes. Uh, but I think it'd be well under an hour in cut time. And let me just go through this. So the NC report shows the part, it shows each procedure, shows the total time for each procedure. You get a little miniature report for each operation. A tool list, and also the motion limits of all the operations.